Good morning, children. Today I will start with the properties of electromagnetic waves. Now, because of the complex nature of electromagnetic wave motion, we will consider here only a few simple properties. You can see in the diagram there is the electric field component and then there is the magnetic field components are represented. There one in the y-axis and one in the z-axis and there one is the x-axis. The x-axis is the direction of propagation. So now these fields are represented in the figure. Now these are as follows. Number 1. The oscillating electric and magnetic field generated by oscillating charged particles are perpendicular to each other and also the direction of propagation of the wave. The electromagnetic radiations have oscillating electric and magnetic field and they are also perpendicular to the direction of propagation of wave. Wave is also propagated in the perpendicular of these two planes. Now these waves do not require any medium for their propagation. No medium is required because you know the light can even propagate in the vacuum that is coming from the vacuum. So the no medium is required for their propagation. Now third point, the electromagnetic radiations are of several kinds which differ from one another in wavelength or in frequency. So the different radiations are there. When the electromagnetic radiations are arranged in order of their increasing wavelengths or decreasing frequency, the complete spectrum obtained is called as electromagnetic spectrum. So in this way the waves are having the different wavelength or different frequency. So when the different types of waves are radio waves, microwaves, infrared, visible, invisible region, that is ultraviolet, X-rays, etc. So the different waves when they are arranged in the increasing order of their wavelength or decreasing order of the frequency is called as electromagnetic spectrum. The increasing order of wavelength of these radiation is as, that is for the cosmic rays, then the gamma rays, then X-rays, then ultraviolet rays, then visible, then infrared, then microwaves and then the radio waves. Radio waves are having the longest wavelength you can say, and that is used for the signal for transmission, and microwaves are used in the radars, and you know the microwaves are other use also, that is in the cooking. Infrared region is having the property of heating, visible is for illumination, ultraviolet are germicidal lamp, that is their uses. X-rays are for taking X-ray in the hospitals, and then gamma rays are used in the cancer therapy. So now we'll see what are the limitations of electromagnetic wave theory. The above theory explains the phenomena like diffraction and interference, but following are some observations that could not be explained with the help of this theory. These are: number 1, the nature of emission of radiation from black bodies, that is called as black body radiation. The second is the ejection of electron from the metal surface when radiation strikes it, that is called as photoelectric effect. Now third is the variation of heat capacity of solids as a function of temperature. Then fourth is the line spectrum of atoms with special reference to hydrogen. Here you have to study only first and second point, that is the black body radiation, and then the second is the photoelectric effect in the detail. So this is about the electromagnetic theory. It can explain the interference and the diffraction phenomena, and then but it cannot explain these four points. Now we will study electromagnetic spectrum. The different electromagnetic radiations have different wavelength. The visible light in the presence of which our eye can see contains radiations having wavelength between 400 nanometer to 750 nanometer. Different colors in the visible light correspond to radiations of different wavelength. We have studied about the light spectrum in the 10th class. So the spectrum is having the 7 colors in the visible light, and these 7 colors are having the different wavelength. Other than visible regions, some invisible regions are also there. So these wavelengths we cannot see from our eyes. That's why it is called as invisible. That means the both side of the visible region there is invisible region. That is, one is called as ultraviolet region and other is called as infrared region. So in this way the waves are arranged. Now for the in addition to visible light, there are so many other electromagnetic radiation such as X-rays, ultraviolet rays, infrared, microwaves and the radio waves. Arrangement of all electromagnetic radiations in the increasing order of their wavelengths or decreasing order of their frequency is called as electromagnetic spectrum. Different regions of electromagnetic spectrum that we can identify, that you can say in the spectrum of electromagnetic radiations. Now we will study the particle nature of electromagnetic radiation, which is called as Planck's quantum theory. Now to explain the phenomena of black body radiation and photoelectric effect, Max Planck in 1900 proposed a theory known after his name as Planck's quantum theory. This theory was further extended by Einstein in 1905. The main postulate of this theory are as follows. This theory was given by the Planck's, and then this is called as Planck's quantum theory. Now the first point of this theory is the radiant energy is emitted or absorbed not continuously but discontinuously in the form of small discrete packets of energy called a quantum. In case of light, the quantum of energy is known as photon. According to this, when a substance absorbs energy, that energy is not absorbed continuously, but there is the absorption of energy in the form of the energy packet. These energy packets, when we talk about the light energy, then they may be having the photons which are having certain energy. So they can absorb either one photon or the multiple of photons, means 5 photons in one time, maybe 10 photons in one time. So that is called as the packet of energy. So the radiant energy is emitted or absorbed not continuously but discontinuously in the form of small discrete packets of energy. They are separate packet of energy called a quantum. Now the second point, the energy of each quantum is directly proportional to the frequency of the radiation. The energy which is absorbed is directly proportional to the frequency, that already know, frequency of the radiation. So then we can write E is equal to E is directly proportional to nu. Energy is directly proportional to the frequency of the radiation, or we can write E is equal to h nu, where h is the proportionality constant called Planck's constant. its value is approximately to 6.626 into 10 to the power minus 27 args, or 6.626 into 10 to the power minus 34 joule second. Now the third point, the total amount of energy emitted or absorbed by a body will be some whole number quanta, that is energy is quantized. And then we can write here E is equal to NH nu, where N is any integer. Now the energy possessed by 1 mole of quanta or photons, that is Avogadro's number n0 of quanta, is called then 1 Einstein of energy. That is 1 Einstein of energy, that is represented by E, is n0 h nu, that is n0 h into C upon lambda.